So hi everyone, I'm Luke Marsden on the Lilypad project. And so Kai and I together in this next session are going to do a sort of technical deep dive into Lilypad. We're going to do some demos. And so please start praying to the demo gods for me. I wanted to start, this is kind of something we've been spending a lot of time thinking about and chewing on, this problem of the tension that exists between determinism and good developer experience. So I wanted to start by kind of explaining what I mean by that, explaining why we need determinism, and kind of take you through the journey that we've been on in terms of getting to what we think is a good solution for this, but it feels like it's a very narrow path that we're on to make this work well. So firstly, why do you need determinism in these systems? Well, the easiest way that we have to do verification, in other words, if I am a compute provider and Ali is also a compute provider, and a client shows up on the network, a job creator is synonymous with client in our terminology, and says, I want you to do this job, please. And I do the job, and Ali does the job, and we both submit our results. How do you know if one of us was cheating? Like maybe one of us wanted to get lots of free tokens by always submitting zeros. So you need a verification system built into the network. And the best way that we know right now of doing verification is simply to take the hash of the outputs and compare them. And so you can have a trusted mediator or a partially trusted mediator or a consortium of mediators in order to check these results. But all of those mechanisms for this kind of optimistic verification approach require that you can check that the outputs are identical. And so you might have systems where the outputs are not identical. Like programming languages in general are not deterministic by default. There's all sorts of ways that non-determinism can creep into even programs that are meant to be deterministic. For example, you can the order in which you iterate over maps in Golang is randomized by the runtime in order to, sometimes I think in order to catch you out, but it's actually in order to surface depending on that map iteration order more quickly. So the first approach that we took to this was, well, maybe we can enforce determinism in the runtime. Maybe we can say that we will ship a WASM runtime, much like FVM does, which is single-threaded, has no sources of entropy, and which we can guarantee will execute in the same way every time. Now, that's great, and we do actually have a deterministic WASM runtime built in, thanks to the Bacalhau project, which we also worked on for over a year. And that's great for kind of arbitrary user-provided computation, but it's not so great for AI/ML workloads, because WASM and GPUs don't mix easily. There is work on that, but it's not ready yet. So you end up with wanting, like, what users need, and what we need in order to make Lilypad as a project successful is this ability to run GPU workloads. And so we had to take a step back and think about the problem from a different perspective. And so what we did was, well, we can say, instead of the runtime enforcing determinism, why don't we separate the people who create the modules, i.e. the code that runs in Lilypad, from the users? And then we can say, dear users of our network, you can't actually run arbitrary code on our network. You can run from a preset set of modules that we have determined are deterministic. And actually, you can kind of spin this as a feature, not a bug, because you can say to the users, look, we've curated this set of great AI modules that you can use to do like stable diffusion or fine-tuning or large language models. And behind the hood, under the hood, we've made them deterministic for you. We can kind of enforce that non-determinism in the, we can enforce that determinism at the point at which you write the module. Because, for example, there are ways to make GPU workloads deterministic that are specific to like the diffusers library by Hugging Face. There are all sorts of things you can do to pin these things down. Okay, so we went down this path. With Lilypad v1, we had, I think, 4 to begin with modules baked into the system that we'd written, that we'd made deterministic, or we were working on making some of them deterministic, but that was the goal, was to make them all deterministic. And then we started showing Lilypad v1 to people at hackathons and conferences and stuff, and online. We got tons of feedback. Everyone wanted to build their own module. And that meant that the developer experience for Lilypad v1 ended up, everyone wanted to run the dev stack of Lilypad on a GPU node so that they could build their own module, so they could make a pull request to the project to contribute their own module to the project. And the dev experience for running GPU nodes in development sucked, to be honest. So that was a major pain point for our last iteration, but it was also a big sort of source of learning. This is what users want. They want to be able to contribute their own modules. So we made modules user contributable. That's one of the major changes, the main user-facing change in Lilypad v2 is that modules are now user contributable. And that means that we have this slightly subtle trust relationship that you need to be aware of. Well, users don't really need to be aware of this, but as the people building the system and also as module contributors, there are going to be some constraints. So, for example, in this diagram, you have the resource provider, which is the node. It's the machine that's actually running the jobs. And then you have the module author, which might be the Lilypad team. And you might say that you're running our software, so you probably trust the Lilypad team, at least to begin with, and we'll decentralize that over time. But you might also want to be able to trust third-party modules that other users have contributed. And so the idea here is to build tooling and use kind of the human trust relationship that we can use to create an ecosystem of module authors. And those module authors will communicate with the resource providers in order to get them to maybe check the code, or just based on the fact that other resource providers have checked it, they will allow list certain modules in the resource provider's configuration. And so, yeah, we're trying to build this ecosystem of people building modules, and then still the user will be able to quite easily trust that the ecosystem of resource providers will be able to run modules that have been verified by humans to be deterministic. We also have a plan to automate checking for determinism. So one of the things that will be quite nice is if you bring a node to the network and it has a GPU, for example, you will be able to run like a self-test of a bunch of different jobs that have known outputs that are published along with the module. And you'll be able to check, oh, does my hardware generate the same answers? If it doesn't, I really don't want to put it on the network, because then I'm going to get slashed for looking like I'm cheating, just because my specific configuration doesn't give exactly the same outputs or whatever. So it's a way of like verifying that your nodes are giving the right answer. Yeah, the goal here is to have a module system which is like late bound and pluggable. So with that said, that's my little rant about determinism and DX. Yeah, as Ali has mentioned. No, it's fine. It's good. I thought we could announce it a few times. We are today very happy to be able to announce that as of 12:30 last night, Lilypad v2 is now live. So Please, thank you. Please come. The docs haven't been updated yet. Like I said, it was a late night last night. But we do have documentation on the README for Lilypad v2. So please go to github.com/bacalhau-project/lilypad and kick the tires right now. If you can break it before I do my live demo, then I'll buy you a pint. Anyway, so yes, we have this V2 that we've developed. I'll just give you a taste for how easy it is, hopefully as a user, to get started. So this is our README. You can just plug in these RPC details into MetaMask. You can go to our faucet, which looks like this, and plug in your address that you have from your MetaMask wallet, and it will give you 100 ETH. This is a Geth-based testnet at the moment, although we are actively working on IPC integration, and it will send you some test ETH and also some test LP, which is the plan name for the Lilypad token. Yeah, this will show up in your wallet. And then you can run a job just by exporting your private key and then doing like Lilypad run. And you can make nice pictures using SDXL, using the SDXL module. So we also have got up to 9 modules now. So you can see on the right-hand side here, hopefully the text isn't too small. We've got SDXL, the old version of Stable Diffusion. We had an external user contributed DuckDB module. We have another external user at a hackathon contributed a fast chat module, which is an LLM. We have LoRa, which is low rank adaptation, fine-tuning on Stable Diffusion 1.5. So there's a separate module for the training step there, which is where you give the image model a bunch of images of things that you want it to copy the style of or want it to look like, and then you can take, and then it will give you a LoRa file, which is like a diff between the weights in the neural network and the trained weights, and those LoRa files are nice and small, which is handy. And then you can feed, and it writes that as an output CID from the training job, and then you can pass that output CID as an input into the inference module, which is a really nice use of it's a really nice example of using IPFS to pass data between jobs as well. And then you can run inference on that. So you can like generate brand assets for your company or something by like giving it a bunch of examples of your brand, and then generating like, I don't know, like mugs and T-shirts or whatever using the inference module. We also have a Filecoin data prep module. I think Anjor is here, maybe, hopefully. Anyway, he wrote the code for that one, and so you can use that to do kind of the first step in onboarding data onto Filecoin by doing that car file generation that supports reading data securely from S3 compatible endpoints. We also have arbitrary WASM. You can specify a CID of a WASM program on IPFS, and the WASM executor will load that. And that is an example of running arbitrary code. So you can actually run arbitrary code on the network. It just has to be WASM code. And then we have my favorite, which is Causa. So I'll show you Causa in a second. But first, this kind of answers Molly's question of like, well, what's the difference between V2 and V1? Like, why did we do a V2? Well, we did a complete rewrite in Golang from the Python version. The Python code that we inherited from the Modicum paper was very good research code because it did the job that was needed to do to get the paper written and to publish results. So I don't want to throw any shade on it at all. And it was fairly, it wasn't production-ready Python, let me put it this way. So we ended up actually, our developer velocity working on the code base was slowed down quite a lot from just running into kind of a bunch of basic stuff, trying to productionize that code base. And so we had a bit of a discussion on the team about, well, should we try and rebuild the plane while it's flying? which is like productionize the Python code base and stick with Python? Or should we like land the plane and then build a new plane while we're on the ground? And building the new plane on the ground actually won in that discussion. But I do have a point here, which is you should never do this. Like there's a thing on, there's an article on Wikipedia called second system syndrome or something, second system something on Wikipedia. I learned about it as second system syndrome. It's this idea that if you have, if you try and build a V2 of something that's already working, it will take a long time. It'll take longer than you think. You'll be tempted to add lots of shiny whiz-bang new features to it because you think they're a good idea. And all the time while you're doing this long rewrite of something, you will suffer from the pain that is that you have users trying to use your original thing and you need to make changes to the original thing. And now you're trying to change the original thing while probably most of the development team doesn't want to touch the original thing because they're busy rewriting the new shiny thing, and the new shiny thing is the good thing, right? So hats off to Kai. Despite these constraints, he got this rewrite done in 3 weeks, which is the fastest I've ever seen a rewrite of this kind of level of code base get done. And I think it was mainly because he was trying to prove me wrong. But it's great. It's good code. We've got an updated architecture, which Kai is going to talk about in a minute. The new code has a token, an ERC20 baked into it, which the original code didn't. It's much, much faster. And we also have a workaround for IPFS slowness by fetching. The client fetches directly from the solver. The solver, I believe, fetches directly from the resource provider, which talks only to a local IPFS server, which already has the data, so it's reliably and quickly able to fetch. So that reduces latency. Okay, so please pray to the demigods for me. I am going to start by doing a cowsay. So I'm going to do Lilypad run. Cowsay is a module which is a repo on GitHub, and v0.0.1 is a tag for that module. And I'm going to pass it an input string, which inputs in v2 are now key value pairs. In the v1, it was just a flat string, and key value pairs are much nicer because you can have some structure without having to like YAML decode the string yourself in your module. And I'm going to say, good morning, Iceland. Looks like the rain has cleared up. And so we then start up the Lilypad client. This kind of is a full client that connects to the network. It submits the job, negotiates the deal, agrees the deal, runs the job. The results get submitted, and then they get verified. And then, in this case, the results were accepted because the proposer of the jobs wasn't cheating. And then we can cat the output, and we get a cow. I wasn't sure whether that would get a clap. So that's the warm-up. The really cool demo is if we start doing some AI jobs with this thing. So, if I can spell rhino. Who wants to shout out their favorite animal? Lion. Okay. So we're going to have a lion. And so this will take a little bit longer. It takes about 30 seconds because the node which picks up the job is a node which is advertising that it has a GPU available to it. The GPU node then it might have to download the Docker image, although in most cases it will already be cached. The Docker image will contain the AI module, the AI model. It's finished already. The AI model will then have to be loaded into GPU memory, which, if it's in the operating system cache on the node, is normally quite quick. And then the actual inference happens, and then it writes the result back out. The nice thing about Lilypad v2 is that it downloads the files directly to your computer. And here we have a lion. Cool. I'm going to push my luck, which you should never do, and try and do one more. Let's see. This one's quite cool. Right. Who wants to shout out another animal? Okay, I'm going to say wallaby. Sorry, I already did octopus earlier when I was testing this, so we're going to try wallaby. Yeah, any questions while this runs? Molly?
Is this microphone? Yeah. How many Lilypad nodes are running the job in order for you to do verification right now?
So currently we have, we would run the job on whichever node, whichever single node wants to or wins the bid to do the job. And then we roll the dice, as it were, to decide whether or not to verify it. Levy can talk about this in much more detail and accuracy, but basically it's kind of like, think of it like a ticket inspector on a train. You might not get your ticket checked every time you ride the train, but you need to get your ticket checked often enough to incentivize most people and make the punishment bad enough for not buying a ticket that on average people tend to buy the ticket. Buying the ticket is doing the job correctly. And so that's a parameter that percentage chance of doing verification, I think, is currently set to 10%. And in the case of that you roll the dice and you get 1 in 10, then we currently have a single trusted mediator as part of the system. But on the roadmap is the plan to decentralize the trusted mediators to a consortium of mediators.
It's worth saying, like, it's completely up to the client, the person paying for the job, as to like what that percentage of checking is. And Levy's going to speak more about autonomous agents, which is like at the moment it's like roll the dice with a certain percentage. The person paying for the job gets to decide what that percentage is. Going forwards, then we can have all sorts of pluggable mechanisms for should I check this or not. So like at the moment we have the substrate, which allows you to say I want to check, I don't want to check. And then how we decide if we check, I think, is an open question we can develop this towards. Because I think at the moment we're like, let's leave a space for that question to be answered by people like Levy rather than like non-game theory people like us.
Cool. I'm actually gonna, if it's okay, please hold the questions because I was just asking for questions while the AI ran. Kai's going to do a bit of a summary of the architecture now, and then we can come back and have questions for both of us at the end, if that's okay. The wallaby. There it is. Nice. Thank you, Stable Diffusion. Okay. Right. Yeah, cool. Go for it.
Thank you. Hey guys, I won't be long because we don't have a huge amount of time. But yeah, first up, like the layers. So it's important to us. Like first statement, we've not gone off and written some kind of execution layer, right? As Luke said, we've been working on Bacalhau for a year. David mentioned Bacalhau. This absolutely uses Bacalhau, and it's important to say that because Bacalhau runs against various pluggable storage engines. If I was to kind of like put one of the original points of doing this out there, it's to allow computation over IPFS and Filecoin data to be triggered from a smart contract, right? And for me, that's kind of exciting. I want to be able to write a smart contract that says, train this AI model on this CID, for example. And kind of we want to bring that capability to the world in the form of libraries. So this lower level thing here is like, hey, I don't really agree with your mediation strategy, or like I want to do something slightly different to how you guys are doing this network. So I'm going to take all of your code and I'm going to put it together in a slightly different fashion. So we've been very conscious of building this in a way that is pluggable like Lego, right? So there's like various libraries you can plug in. You could say, I'm going to ignore all of the mediation thing. I'm just going to use the smart contracts. I'm going to reuse Bacalhau in the same way that Lilypad is, or I'm going to use a different executor. An idea I have is to plug in a Kubernetes executor, for example, because like, hey, I have a whole fleet of machines. I kind of need to earn money because computers cost money. So how about I run a Lilypad resource provider at the edge of my Kubernetes cluster, for example. So I'm just giving an example there of how we want people to build other networks using the code that we've built, and it's only going to help the ecosystem. So one layer up from there, what if like I want to hang off of the existing market? So hopefully there's going to be liquidity in this market. There's going to be resource providers saying, here I have computers. There's going to be job creators saying, here I want to pay for people to do jobs. Like if somebody else wants to run a slightly different solver algorithm, we'll talk about what that is in a second, or a different mediation process, there's nothing stopping people hooking directly onto the smart contracts that are actually holding the Lilypad token. So it's slightly different to code libraries. It's like I want to attach to the actual running Lilypad network with the liquidity, but I don't want to use the off-chain code that we are shipping alongside the rest of the project at the moment. So it's like there's nothing stopping people speaking directly to the smart contracts, is what I'm saying. The next layer up is the Lilypad network itself, which is what you guys just saw generate those cool animal pictures. And that is like code we've written that hangs off of the smart contracts, but it's kind of like our opinion about how this should work. There's nothing stopping anybody having a different opinion, because that's the whole point of decentralized networks. The top thing, something we were absolutely intending to work on over the next few months, is like I have no idea about anything these people are saying, but I do want my wallaby picture, right? And so it's like I want to go to a thing, I want to put my credit card in, and I want the picture back out. And so underneath, then we can convert that Web 2 thing into tokens, get the job done, return the picture, and we're hopefully then exposing this whole stack, IPFS, Filecoin, Bacalao, Lilypad, to people who have no idea what that stuff is. They just want the value back out of it. And so like I think this is a good mental model for like how we see the world. I'm just going to run through this fairly quickly because I could indulge myself all day, but like nobody's ain't got no time for that. So the controller, I'm just going to talk about what the smart contracts are in this stack, right? They're all very standard Solidity. We're not using, the only funky trick really we're using is like some contracts speak to other contracts, right? Which is, I wouldn't say that's a mad thing at all. So let me just talk about the role of these various contracts. Probably let's start at the token. It's an absolutely standard ERC token, ERC20 token. It's the Open Zeppelin base. The only tweak we've made, obviously anybody, as is common practice, can look at the code before they trust running it, right? It's all there, it's open source. The only tweak we've made to the vanilla Open Zeppelin token is to add an escrow feature for the payments contract to be able to manage escrow on behalf of running jobs. But as you can see, this line here, this one, like if I own tokens, I can communicate directly to the ERC20 contract and just move tokens as you can in a normal contract. It's very important that people like trust that, right? It's like, hey, look, there's no kind of smoke or mirrors about your tokens. It's a standard ERC20. The payments contract just there is a kind of a wrapper, if you like. It kind of says, hey, there is a job in flight. I have taken the escrow on behalf of both parties. Once we have a mediation decision, I'm going to release that escrow in various directions, or I'm going to slash that escrow because the decision has been made that somebody cheated. So the payments contract is essentially a manager of the token on behalf of a job. The storage contract on the left-hand side, this is basically like the history. So if in some ways, look at the storage contract as like the reputation contract, might be how you call it, but it also serves a purpose of just remembering what happened at a base layer. And that, you know, that's really useful for reputation. And there's a huge amount of game theory stuff that me and Levy have gone through where reputation actually becomes a very important aspect in deciding what you want to do when it comes to agreeing to deals. The mediation contract here is a pluggable mechanism for how we decide to mediate. And so we've started off with a very simple implementation. Again, I don't to go down too much detail, but like the resource provider and the job creator, when they agree to a deal, they have an intersecting list of trusted mediators, right? So it's like, hey, if we have a dispute, I trust this person to resolve the dispute. This other side also agrees with that. We then pick one at random on chain, you know, okay, it's pseudo random. But the point here is that we can upgrade the mediation contract later on to support things like consortium of mediators, which Levy, I'm probably we'll touch upon. The last part is the controller. This is the thing that just brings everything together, right? So the controller really is just like the thing that understands the existence of all of these other contracts. The services, these are off-chain services, apart from the pink box. These are things that are listening to events coming out of the contract and will react. So, for example, the resource provider, when it hears, hey, a deal has been agreed to, the escrow money has been paid into the contract, I'm like, okay, cool. As long as I run the job faithfully, I know that money is there, because even if the job creator says, hey, you didn't run that, the mediator would kick in and say, yes, actually, the resource provider did. And so I can faithfully allocate my compute resources knowing full well that the money is in the contract. So the various other services, the solver is the thing that's kind of hearing about offers being made. The key fact about this design, if I skip to the next thing, the solver is kind of like a suggestion machine, is how I would say it. It's not like, oh, you have to do what the solver says. That sounds far too trusted for me. It's not on-chain is the point. And the point of that is that it opens up interesting design patterns for future scheduling. So what I mean is, like, imagine somebody comes up with an AI model, like, hey, I've got the best scheduling algorithm in the world. Awesome, run it as a solver, and everyone can start creating deals via whichever solver they want to. All the solver is doing is suggesting matches. And so it's eager. It's like, hey, here's a match, here's a match, here's a match. Both sides have to agree to the match before money's involved. So the solver isn't really a trusted entity. It's more like a, hey, you could do this if you fancy doing it, right? And so both sides say, oh, that looks like a reasonable suggestion, I'm going to do that. The job creator is the client, the CLI / the on-chain. We'll talk about that maybe in a later stage. But the thing that's running the job, the resource provider, is the thing that has the compute. The solver brings both of those offers together, says, well, you match. For example, I need a GPU, I have a GPU, good example of a match. There's pricing in there, like what am I willing to pay, what do I charge, etc., etc. The solver suggests the match. Both sides agree to the match on-chain. And what does agreeing look like? Submitting a transaction into the controller contract that involves paying the escrow in the form of tokens. And so the moment you agree, now we're kind of like getting down to business. So the solver isn't really involving any money. It's just suggesting how you may agree to a deal. So once a deal is agreed, the resource provider notices and says, oh, cool, I'm going to run the job. Absolutely, that's just saying, hey, Bacalao, run the job. We're using the Bacalao job spec as the core way in order to express what a job is. So we're not kind of going off and reinventing the wheel. We already have a very nice wheel, thank you very much. And so Bacalao is essentially the thing that runs the job. We're just coordinating Bacalao to get round to that. Once the result is pinged back via the smart contract, the job creator says, oh, awesome, I have a result. It decides if it wants to challenge or not. As we said earlier from Molly's very good question, like how we decide is an open question and pluggable, because the job creator is just a client. It's an off-chain client. It can decide however it wants. A healthy ecosystem for Lilypad going forwards is where people are writing various modules and extensions for how we might decide that, right? So that's a game theory question, a lot more. If the results are challenged, right? Hey, I want this ticket checked, please. I don't think I trust it just verbatim. The mediator service kicks in. The mediator is that kind of mutually trusted service. You have to both agree about the same mediator being part of the deal before the mediator kicks in. It will run exactly the same job. And now you can see why Luke was making a massive point about determinism, because if the job itself isn't deterministic, the mediator is going to come up with a different answer. And that's how the mediator can ping back into the smart contract. Yes, the resource provider did do its job, or it didn't. A really good example here is what if the job itself is just an error, right? So actually, that's called a successful run of the job, because if the resource provider runs what the client has submitted and it comes out with, I don't know, exit code 127 or something, the job creator might say, well, that's not cool. I didn't get my image back. I got an error. I'm going to challenge it. The mediator runs the job, exit code 127, the resource provider gets paid, right? Because that's the job creator's fault. It's not the resource provider's fault. So it's a very important sense of determinism in this slide right here. Yeah, I've kind of combined both of those slides. There you go. I'm gonna not overdo the time, because there's we have the rest of the day to talk about all the rest of the stuff, and I'm very happy to talk all day about it. So thank you. I'll pass back to Luke.
Cool, thanks. So, yeah, I think this is the last slide. I just wanted to share a little bit of our roadmap. So we have some UX, DX improvements planned, of course. This is very fresh code, only got deployed late last night. But for example, when I was running the wallaby picture, I had to specify the prompt using this kind of ugly prompt env equals prompt equals thing. We're going to fix that. We're going to deploy an IPC. That's what we're going to spend a lot of time in the next 24 hours talking about. There's an IPC Fendermint deployment, which in theory we have validated that the Go client that we are now using will work against, although the Python client did not work against. But now we're not using Python anymore. That shouldn't matter. We're going to move to a consortium of mediators, which Levi might talk about. We need to audit those smart contracts. We want to do some stress testing of the system, build up some big clusters, throw tons of jobs at them, see what breaks, fix it. We want to do data-aware scheduling. That's not in the system yet, but it will be. The idea that if a Filecoin node has a bunch of data and you want to run the compute where the data is, which is the whole point of compute over data, then we can do that. That's mostly just plumbing, like plugging together things that already exist, so it shouldn't be too hard. We want to add some more subcommands, like Bacalhau has some lovely subcommands for list the jobs that I've run, describe a job, give me the status of the job, tail the logs of a job while it's running. Those tailed logs probably wouldn't be verified, but they would be like a service that resource providers can offer to users, and probably should, to say like, oh, I want to see how my like long-running fine-tuning job is going, like kind of 5 minutes into a 10-minute job or something. And then that's all leading up to this incentivized testnet in November, which we'll talk more about soon. Ali's got the sign-up form for that, so please come and talk to Ali if you're interested in participating in that. And then right at the bottom here, I've got, I want to add encryption between the resource provider and the job creator so that we can start having not completely public jobs running on the network, because I think that's going to be super important. That's it. That's my brain dump on the roadmap. So yeah, thank you. A few questions here. Kai, can you come up and help me answer questions? Cheers.
Hey, I'll start. So you started your presentation with a point about determinism. Mm-hmm. And when I intuitively, and maybe I'm wrong about it, but when I intuitively think about like AI type of jobs, like when I interact with Midjourney or ChatGPT, they are fundamentally non-deterministic. You can run the same thing multiple times, you get different results, and this is a kind of part of the fun. How would you kind of like combine these two kind of contradicting points in your system?
Yeah, so it's a very good point. So GPUs are just massively multi-core computers. Let me just find, sorry, I'm going to not try and talk and use my computer at the same time. There's a really good page on the diffusers docs about creating reproducible pipelines. So yeah, I mean, GPUs are just massively multi-core computers doing lots of matrix multiplications usually. There's no reason in principle why they can't be deterministic. However, there are sources of non-determinism that come from multi-core computation, like scheduling jobs across different CUDA cores, and different things taking slightly different amounts of time to run, and then kind of merging those results back together. And the way that you do that can impact on whether you get the same answer every time. There's also some horrible things like stochastic rounding. I don't know if you're familiar with that. It's this idea that you can get better results from doing like a training of a model if you use on-device entropy to randomly round 0.5s up or down a percentage of the time that corresponds to kind of giving you a bit of extra precision. I don't know if I've explained that well, but you can look it up. The nasty thing about that is it's on-device entropy, so you have to turn that off. So there's a bunch of kind of knobs and dials that you have to turn off in order to actually get the damn thing to give you the same wallaby every time. But it is possible, and if you go right down to the bottom of this document, then you say, now when you run the same pipeline twice, you get identical results. And you have to set a bunch of weird random environment variables and so on, and configure your pipeline in the right way. And this is for PyTorch, so it's going to be different for other things, but it is possible.
My question was not about possibility, about like, should we, like maybe users want non-deterministic
So we
results.
can pass in random seeds.
Yeah.
So we already support passing in random seeds. So in the STXL module, for example, if you want a different wallaby, then let me see. This is. That would be a good test. I'm not in the mood for more demo. I'm pretty sure it'll work, but we're running out of time. So yeah, if you pass this seed env variable, then it defaults to 42. But if you change the seed, you'll get a different answer. So it's possible to give the user the ability to change the result if they don't like it. Like they can roll the dice again. But under the hood, this is a different job. It's got a different input. It's not going to be verified against other ones. Yeah.
It's worth saying as well, like, it's not like, hey, we've managed to make everything work in the way it should. It's like some things will work really well on Lilypad, and some things probably just won't. And I think that's the point of modules. It's like, hey, you can do this, this, and this, and this. And so, like, the claim, hey, we've managed to make everything work deterministically on this network is definitely not what we're saying. And I think that's the point of the module boundary. It's like, hey, with Stable Diffusion, using the random seed, I think there's a healthy balance between determinism and, random results if required. So I think, but it's an important kind of in the spirit of Lilypad statement, like it's not everything will work. It's more the modules we have curated and more importantly, resource providers have agreed to run because they're the ones that risk getting slashed if the result is different. That makes sense? So like it's, the module system I think is the real kind of the way to solve that.
And this is why I call it a narrow path to determinism and good developer experience, because you need to balance both these things for it to work. But the module system is nice because it allows a ton of value to get delivered to the end users. It's because they get this array of cool things they can do with real business use cases associated with them. Sorry, Ali, I'll just finish. We've also tested the performance impact of enforcing determinism for STXL. It's negligible. It's like adds 1 second to like a 15-second inference. So for a subset of use cases, we'll be able to make them deterministic with good DX. Ali, go ahead. Do you want to come up and talk into the mic for the recording?
So I'll just quickly add to that. I think you could create a module if you wanted 5 images that are all different at once. Just create a module that does that.
Yeah.
As from a user experience or developer experience perspective.
Lots of questions.
I might have missed this, but I guess I'm trying to understand. You said you had an optimistic kind of like challenge model, and that was the mediator was the one that was in some ways doing this. I guess I'm curious, in a like traditional kind of like sequencer example, you're making that data available publicly on chain so that anybody can take that and challenge that. I guess I'm curious, is that what you're doing right now? And like you're storing enough data publicly available on chain so that people can recreate the computation? Or is that just passed directly to the mediator themselves in the current implementation?
It's public. Anybody can see what the result is. But before the resource provider will kick in and run the job originally, both sides have agreed to the mutually, in the case of that one job, the mutually trusted group of mediators that will check the ticket if the job creator decides. So everyone can see, hey, this is what happened in the end from the job. So like, for example, if you're like, oh, I just want to check myself without actually being a mediator if that was true or not, you could also rerun the job yourself and see if the mediator actually was lying or not. And there's a whole world of like, how do we even check the mediators that me and Levy have been talking about, but like now we're going into the depths of the game theory. But to answer your actual question, like the results are publicly published on chain before the mediator kicks in and checks them.
Okay. So the results and like enough data that I could recreate the entire transaction myself.
Correct, yeah.
Luke, you mentioned about you had some optimizations for IPFS to keep the latency down, or some caching or something like that. Are you also looking to fetch from Filecoin? Are you going to be using something like one of the Lassie, as a library or something like that, or how are you doing that?
Very important to say, like underneath the hood, it's using Bacalhau.
Okay.
So any storage provider that Bacalhau supports, Lilypad supports.
Okay.
So the moment that Bacalao rocks up and says, hey, look, here is the Filecoin retrieval market storage engine, Lilypad will magically support that because we're not adding our own sense of like storage retrieval or compute execution sort of definitions. We're just passing, literally, the Lilypad job spec is a Bacalao job spec. So as soon as Bacalao, and like there's a whole team that David manages that is working on all of these sort of, hey, where is Bacalao going in the future in terms of what storage engine it supports? So I think the real answer to your question is like as soon as Bacalao supports it, Lilypad does. And then there is the other thing I mentioned, like, hey, you could actually just run a Kubernetes executor for Lilypad, which kind of bypasses Bacalao. So we could actually just go, hey, well, Bacalao hasn't got it yet, but I want it now. And so you could just write your own executor, and resource providers then are able to choose which execution engine they want to trigger the job with. The key statement is like the job spec is the Bacalao job spec. So if you were to write a Lilypad execution module yourself, you'd have to convert the Bacalao job spec into whatever it is you want to run. So for example, the Kubernetes thing would be like, take the Bacalao job spec, which kind of like basically maps one-to-one onto a pod spec, like it's the same constructs. But yes, I think we've made the right choice in saying like Bacalao's already got a job spec, let's not go and invent another one. Mm-hmm. Does that answer your question?
Yeah, it does. I mean, where I was going with that as well is, speaking yesterday to somebody, one of the ideas was about a sort of an asynchronous way of loading data into FVM, right? And I was just wondering whether Lilypad could potentially be used for that, i.e. you emit a Lilypad, job that is run that basically fetches some data from Filecoin, maybe does some extraction from that CID, but then passes the actual data back to a smart contract, rather than using some sort of more, generic Oracle type software. Could Lilypad fit that role?
I think that definitely could be a use case, yeah.
Yeah.
Fook, you are next, or do you want me to go? Fook isn't paying attention, so I'm going to go. I was curious, related to this question, how do you handle like data availability of passed-in inputs to a Lilypad job? Because, for example, I believe Bacalao will allow you to be like, hey, fetch the content behind this CID and then do the job over it. And obviously, if the content behind that CID disappears before the mediator is able to do it, or vice versa, is only available to the mediator and not available to the compute node that bid on and was able to fetch that data, that's an interesting challenge. And so I'm curious how you guys have been thinking about that problem and that sort of availability.
I'm going to say, that's an interesting challenge. Because otherwise, like, I'm just making
open problem. Let's talk
absolutely.
about it.
I mean, it's a really great point. Yeah.
I think there is a concept of the directory in the architecture that currently is part of the solver, which does address some of the data availability challenges, and maybe Levi can talk more about that.
Yeah, I mean, that's a really good point, actually. So the idea of the directory is like, hey, here's a job spec. Now, we didn't want to like get into the mode of like publishing entire job specs on chain because gas and speed, etc. So yes, actually thinking about it, this is a really good link to your question. Like, how can you guarantee that the mediator and resource provider can access the job spec? That's the role of the directory service. The directory service is like a mutually trusted thing. It's actually at the moment in the solver. I think it's more of a conceptual idea that like the directory service is the data availability thing. But that applies to job specs. I've not actually thought, also input data is the same thing. So yeah, I mean, it's a good point. But like maybe, I don't know, maybe we could think about the same kind of approach there where before jobs are done, we want to both trust that the data is available, therefore we're going to check that via a centrally trusted thing in the same way that the solver and the mediator is trusted, if that makes sense.
Yeah, and the thing, Matt, who asked the previous question, who, has been, and maybe Scott, who was somewhere near, no? Some people have been thinking about using IPC related to like caching and data availability of like, great, like let's stick this data on chain temporarily as just a holding place, might be an interesting, like the power of many different IPC subnets. It's like, great, we'll cache it on that subnet for the period of time where we're doing the job in the mediation. And then we don't have to worry about some of those things.
I mean, that would be awesome. Yeah, if we could say the data is on, I tend to go like the data can't be on chain, but all of a sudden there's this amazing scaling thing called IPC. So
yeah, you also have the thing of obviously the job runner is highly incentivized to make sure that the mediator gets the access to the data
Correct.
that they have. And so as long as the original person who bids on the job validates that they can fetch the content behind that CID before they put their money in escrow,
Yep.
then they can serve the content behind that CID to the mediator. And if they don't, they're going to get slashed. So like they will, right?
Yeah, no, that's perfect. And I have to say, in this whole project, for me, it's been really quite exciting and interesting to like go through all of the game theory aspects, because that's a new world for me. So like, you know, props to Levy for like essentially riding on his coattails when I stand up here and I say, oh, look, this is how it works. Like, you know, but yeah, it's a new world for me, this game theory part of things. And props to you guys for having started that off, right? So.
Cool. I think we're at time.
Can you expand a bit more on the incentives and the slashing mechanisms?
Oh, that's a perfect segue into
There we go.
Levy. All right, so we have one more question and then we'll move to Levy. Guys, do you want-
I wanted to ask, first of all, why did you build the first version on ETH, on Ethereum, and not on Filecoin?
Oh, great question. I think the real answer is because we absolutely, our kind of laser-focused goal is to deploy this on IPC, and IPC supports Solidity and EVM, and I have done a whole bunch of smart contract development is really the upfront answer. So like, it's because we knew it would work on IPC, and we were capable of delivering it in that form, I think is the succinct answer to your question.
Yeah, we're collaborating closely with the IPC team to deploy as soon as it's ready.
And the second question is, sorry for stealing that. It seems like your business model requires an independent coin. Is that true, or do you have another source of revenue?
Do you mean like as in we have an ERC token that you pay for jobs with?
Yes,
I mean,
because
we,
if you deploy on IPC and we still don't have support for independent coins, what are you going to do?
but then I suppose the token, the coin, is not a different coin, it's just a smart contract. So the ERC20 is the token. So I think it does support a new token.
I think we have a couple of different possible business models and happy to talk about it afterwards. I think we're at time.
Good question.
Yeah, cool.